Hello, this is Vaclav, and in this video we're gonna have a look at the envelopes of the NEO Trinity. In Eurorack, typically when you think of rhythm, you think of triggers and gates, and then you use them to feed the envelopes. On the NEO Trinity, we've merged these two concepts together, and we created very powerful rhythm generator where you can also automate the envelope lengths and create very dynamic sequences. To simply trigger the envelope, hold Shift and press Rec. To change the length of the envelope, turn the rate knob. We'll get back to the different envelope shapes in a second, but first let's get some rhythm going. The automation has two parts, the triggers and the rate knob automation. Let's start with the tricks. To record the trigger into the automation, hold the Rec and keep pressing Shift. And now it's looping. If I would want to erase just some of the tricks, I would hold Mute and hold Rec, and that would delete those tricks. I can record some more. And if I would want to clear the whole sequence, I double tap the Shift button. Let's record something new. So now the sequence is quantized to the clock, it's playing 16th notes. However, if I would hold the channel button and press clock, that would turn off the quantization. So you can hear it's a lot sloppier, or you can say groovy. And to turn it back on, hold E and press clock again. Let's clear this sequence. There is a different way how you can generate rhythms, and there is a trigger generator. To access it, I will hold both Shift and Rec, and then I can turn the rate knob. And now it generated a new sequence. Right now it's generating Euclidean sequences. And the rate knob sets how many triggers there are in the Euclidean sequence. Yeah, very nice. I have different algorithms for this trigger generator. So if I'm holding both Rec and Shift, these channel buttons show me the different algorithms. E is for Euclidean, D is for divider. So that will do these like very regular patterns. So that's sometimes very useful if you just want metronome or something. Then there are ABC, and they are, let's say, preset banks for kick patterns on A. And each one of them has 8 different predefined patterns. B is for snare patterns, and C is for hi-hat patterns. Then there is F, and F is random. So each time I move the rate knob, it's gonna generate a new random sequence. But based on the position of the rate knob, there's gonna be more or less triggers. Let's make another Euclidean sequence here. And I will use channel D to give me another rhythm. And now on channel E, I will change the sequence length. And to do that, I hold the Rec button and I can press one of the channel buttons. So now it's just 4 steps, 2 steps, 8 steps, 16 steps. But what I would like to do here really is to make it 12 steps. So I'll have a polyrhythm. So I'll choose 8 and I will be pressing the plus and minus buttons, clock and mute, and add 4 more steps. 1, 2, 3, 4. So now I have this polyrhythm going. I think that's really nice. What I can also do is to take the whole sequence and rotate it, push it a few steps further or back. So I would do that by holding both Shift and Track and then pressing either plus or minus, clock or mute, let's say 2 steps further. And now the whole sequence shifted and the polyrhythm has a bit of different downbeat. Now that I have 2 voices going, it's really nice to use the mute function. So if I hold the mute button, I can mute both or just one of the voices, or maybe just mute the pitch modulation. No, this is the pitch modulation. And unmute it again. So this is the performative part of the sequence. Okay, so now that we have a rhythm going, I can tweak the rate knob and even record. Record the automation of the rate knob to make it more alive and dynamic. I can delete the rate automation by double tapping the rec button. So now that we have this rhythm, let's look at the different envelope shapes. If I hold the Shift button, I can change the shape by pressing A, B, C, D. So A is a simple decay envelope, shortest to the left and longer to the right. B is a variable shape. In the middle, it's the shortest, and to the right, it's a longer decay envelope, and to the left, it's both attack and decay. And this is very interesting because you can automate short pulses, longer envelopes, and then sort of like reversed type shapes. Let's clear the automation. Shape C is a simple attack envelope. Shape D is a pulse, so it's not really an envelope, but it's a pulse, and you set the width of the pulse. Let's go back to the variable shape, Shift B. And now we have 2 different behaviors. Shift E is re-triggering. Now it's activated, so it always triggers. If I turn off the re-triggering, it will need to finish the envelope shape before it triggers again. So I can skip triggers just by making the envelope longer. And make these like rhythm variations just by changing the rate of the envelope. And re-enable re-triggering by Shift E. Shift F enables the slew mode. or the attack hold release mode. They are actually the same mode. And now it responds to the durations of gates rather than just simply triggers. Let's clear the sequence so you can see what I mean. So if I recorded those gates, it will keep holding them while the gate is high, and then it will release them. So this is more for like a durational type tones. Of course, I can just use the decay envelope, that's also fine. Now let's have a look why it's actually called a slew mode. Let's clear this, and I will feed voltage from another CV Trinity into the input of E. I'll also show it on the oscilloscope. And I'm just gonna change the input mode of channel E into the trigger. I do it by holding channel E and pressing the mode button until only this one lights up, the one that indicates trig right next to it. And now, if you look at the scope, the green line is the output of my envelope, and the blue one is the incoming voltage, and you can see that the output of E is slightly behind what I'm inputting, so it's a slew limiter. It takes the time that's proportional to the attack and the release of the envelope to catch up with whatever voltage I'm sending in. So now I'm just controlling volume with it, but typically you could use it to control maybe a pitch and create slides with it. But slew limiters have quite wide range of applications in modular systems. Now that I have the envelope channel with its input set to trigger, you can see that I can basically use it for external triggering of the envelope. And that's regardless of the behavior. So now I'm in the slew mode, which means the attack hold release mode. If I would disable the slew mode, it would basically only respond to triggers. To get more detailed description of the input modes, we've made a separate video about that. The link is in the description. Now let's look at some interesting patches regarding envelopes using the different input modes. I'm gonna generate another sequence here, and I will change the input mode to VCA, holding E and changing the mode. So now I'm in the VCA mode, and that means applying voltage will make the envelopes louder, but also going negative will invert the envelopes. I can't hear it because I'm controlling a VCA and that rejects negative signals, but this is a way how you can invert the envelopes. When talking about envelopes, it's common to talk about how they are exponential, linear, logarithmic, or even more exponential. So how would you do it on the NEO Trinity? I would select the input mode to be, let's say, positive. I'll go back to just the decay envelope, so it's gonna be a little easier to see. And I will take a copy of the output of the envelope and patch it into the input of E. And you can see that the envelopes basically became logarithmic. And I'm gonna give it a bit few less triggers so it's easier to see, or almost linear. So by this way I alter the shape of the envelope. It's basically making the envelope go slower at the top, and you get the idea. If I change the input mode to attenuated positive, it's gonna be something in between the normal exponential shape and this logarithmic, so it's kind of linear. And if I go to the inverted mode, so it controls the rate in the inverted way, I will get like super exponential envelopes. So you see they have like very steep descent and kind of longer tails. But if that's too much, there is also the attenuated inverted mode, and that gives me something that I quite like for percussive sounds. You can also use the envelope mode to convert triggers into gates. So I'm gonna feed this trigger sequence from the other NEO Trinity, you see it in blue on the oscilloscope, to the input of E, and we'll also change the input mode of E to trigger. And now the shape of my envelope is D, and that's the pulse width, basically. And I can either make it even shorter or longer and convert it to gates. And I can also automate that. And if the gate is long enough that it can bridge several triggers, it will basically not let them through. And that's also how you can generate trigger variations. Okay, let's make it shorter. And let me show you how you would approach a probability. I can use two inputs. I can also use the meta input to control channel E. And I have some random voltage generated on channel F, and I will patch it to the meta input. And I will now change the mode of the meta input for channel E by holding Shift, pressing the mode button. Now I selected the positive mode, so it's basically randomly moving the rate knob, but it's adding to the rate knob. So if I steer the rate knob all the way to the left, it still keeps the rhythm, but now it makes some of the gates much longer, and therefore it keeps skipping triggers. So this is how you can do probability on the NEO Trinity. So these were just some of the examples how you can create very powerful rhythms with the musical envelopes of the NEO Trinity. This was Václav, and I'll see you in the next video.